Hello, and welcome to this panel discussion about how automation multiplies manufacturing productivity as part of our Realizing the Potential of Industrial Robots series, sponsored by Rockwell Automation. My name is Matthew, and I will be your Global Spec moderator, and I want to review a few housekeeping items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface for today's webinar. The large window with the heading Presentation in the upper left is the primary window for today. Just to the right of the main presentation window is the Speaker Bio window, with background information on today's presenters. Just below that is the Q&A window. At any time during the presentation, you can enter a question into the box in the lower section of the window and click Submit. Your question will be placed in the queue to address when we get to the Q&A session. At the bottom of your screen, you will see additional buttons to enhance your webinar experience. To see what a particular button does, just place your mouse pointer over it and a tooltip will appear with a description of the button's function. And now, I would like to introduce our moderator for the Realizing the Potential of Industrial Robots series. Let's welcome Edgar Sauter. Edgar is the Senior Director of New Product Technology at CSA Group. He and his team look to the technology horizon for new developments and applications that could present opportunities for CSA's test, inspection, and certification business. To read more about Edgar or any of our presenters today, please look at the Speaker Bio window right next to the main presentation window. And with that, I would like to pass things along to Edgar to lead us through today's discussion about how automation multiplies manufacturing productivity. Edgar, welcome to today's event.
Thank you, Matt, for the introduction. I am Edgar Sauter, Senior Director of New Product Technology at the CSA Group, and I will be moderating our panel discussion today. We are thrilled to have you here as we have this excellent panel of experts and other professionals in robotics to discuss how this technology is transforming manufacturing and other industries as well. So with us today, we have Aaron Prathner, who is the Director of Robotics and Autonomous Systems for ASTM International, where he oversees standards development, training, and workforce development efforts, and R&D funding. Aaron has written numerous articles about robotics and their role and impact on workforce development. He is on numerous boards and committees that develop curriculum for robotics training. We also have Craig Schlenoff, who is an Associate Vice President for Standardization at the IEEE Robotics and Automation Society, as well as the Program Manager for NIST Measurement Science for Manufacturing Robotics. He has led multiple million-dollar efforts addressing performance evaluation of automated vehicles, industrial robotic systems, and advanced military technologies. He has published over 150 journals and conference papers, guest-edited 3 journals, guest-edited 3 books, and written 4 book chapters. We also have with us Dean Phillips, who brings 34 years of smart manufacturing experience. He is an advisor to the SME Smart Manufacturing Advisory Committee. He is also an accomplished speaker in IoT, AI, robotics, and AR/VR. He is also an entrepreneur and has served on the board of directors also as an advisor for multiple technical committees. With us, we have also Andrea Key, Managing Director for Silicon Valley Robotics, an industry group supporting innovation and commercialization of robotics in technologies. The Silicon Valley area is home for the world's largest robotic and AI cluster, with over 600 robotic companies and more than 50 robotics AI research labs. Andrea is also the VP of IEEE Robotics and Automation Society Industrial Activities Board and the Deep Tech Lead for the IEEE Entrepreneurship. She's also involved in global standards development for inclusive and ethical, autonomous, and intelligent systems. And we also have Leanne Bean, who is Industry Sales Director for Rockwell Automation for warehousing, e-commerce, and logistic industries, with areas of focus including supply chains, robotics, and workforce challenges. So Leanne, Andrea, Aaron, Craig, and Dean, thank you very much for being here with us today and share all your knowledge and experience with our audience. So one of the biggest challenges that manufacturers have today is to hire and retain workers. Robotics is changing that. But is it the same for big and small companies? What are those areas where robotics is helping more? And what challenges and opportunities are robotics bringing to not only the manufacturing industry, but like all across the board of industries? So these are some of the topics that we will discuss in our panel today. But before we start, let's have some moment to acknowledge our sponsors for the series. So Rockwell Automation is a global leader in industrial automation and digital transformation solutions. Rockwell's inherited expertise in industrial networks, sensing technologies, and digital software means it is one of the preeminent authorities for everything related to smart manufacturing. For more information, visit rockwellautomation.com. This webinar is hosted by Global Spec, the world's largest online destination for industrial product sourcing and engineering information. So without further delay, let's start our panel discussion for today. And I want to start with a very generic question. And it's a question to help us understand how is this technology, robotics, impacting manufacturing. So if we have to compare what we have 10 years ago, what we have now, how can we describe the impact of robotic and automation in the manufacturing industry?
Well, I think you really starting us off real good there, Edgar. And I think you're going to get a lot of good answers from this panel, to say the least. You got some great experts on here, folks I really like also working with on this topic. And I think what we need to look at is manufacturing today is not your grandfather's manufacturing of the past. It is much more cleaner. It's much more automated. And it's what's changing now is in the past 10 years, what we're starting to see, and COVID and the pandemic really accelerated this, is the beginning of reshoring or nearshoring of manufacturing back to their home countries in a way, or being at least closer to their end customers. And robotics is allowing that to happen, because what we're starting to see is there are not many low-cost countries anymore. China now is actually, it's not very cheap to manufacture, then ship product all the way across the world anymore. And so now, as you highlighted earlier, is we also have a labor issue on top of all this. While this nearshoring and reshoring is happening, we have baby boomers retiring en masse, and oddly, the next generation, Gen X, which is my generation, we're just 8 years away from hitting our retirement age as well. So you have all these forces now coming together. And where the beauty, though, that lies in all this is we have robots and automation now to a certain level of development that you can now augment your workforce and actually free up your limited workforce by giving those dull, dirty, dangerous tasks, those low-hanging fruit tasks that are on your floor, to the robots to free up your human capital to go do more important things. Best example I can think of right now is a CNC machine. You have to put raw material in, it gets worked, and then it has to come back out. Now, you could leave a person at that machine to do that task, or you could get a robotic arm that will put your raw piece in, wait for it to be done, and then take it back out. And during that time, that person could be doing other things. They could be setting up other machines. They could be placing orders. They could be doing inspection of a part. They could be doing so many other things instead of standing by the machine just watching a part being made. Let the robot do that. So these are the kinds of opportunities now that exist. And I know we're going to have a bunch of other great stories during this panel from everyone else, but the whole thing is while it's scary that we have a labor crunch right now, we have the technology available to us to actually address these things.
Thank you, Aaron. Now, before we jump into the how the penetration of the robotic technology in North America, I would like to understand really how far are we to cover all the needs for the manufacturing industry about the use of robotics. And then I think we have a discussion at one point where we talk about the type of N effectors that can be used for robotics and how to they handle is the robotic technology when it comes to the EN effectors ready to address any challenge that the manufacturing industry have today? Dean?
That's a great point, Edgar. I would say that there's still a lot of new opportunities that are coming up every day. Everything can't be solved simply by saying, I'm going to use one end effector and it's going to come up and it's going to grab the bottle and that's it. There's new end effectors all the time that can mimic a hand where you have one actuator that's doing the grabbing. There's also sensor technology that has to be incorporated into that. There's even where you can wrap around and grab like a squid or an octopus style that actually grabs the object you're trying to lift or pull. There's still some mechanisms that have to be worked out within that, because it does have to, you have different types of products. You can't compare a sheet where it's a sheet metal part that you're putting into a machine with something that I'm lightly have to just barely pick up. And if I touch it or squeeze it too hard, I could damage it. But the end effectors right now with 3D printing and additive manufacturing, we can do so much more. We can customize and fit to the specific product we're doing. So it's a great time to be in that aspect of it. I look forward to the future. I think that we're going to have new opportunities growing for robots every day.
That sounds great. Thank you, Dean. Now, a quick question, Lian. Now that you are familiarized with also the customers that buy this type of equipment for their own applications, so what challenges do you see that they are having when implementing this technology in their areas?
Yeah, that's a really great question, Edgar. And that's something we talk to customers about every day. I think the biggest challenge we see is that there are a number of constraints that are forced on the manufacturers today. We talked about the labor crisis. That's not the only constraint that they have, but everybody's very quick to make an investment in a reactive mode. And I think that as you try to scale that investment, this becomes much more challenging. So there's a lot of factors at play. But I think that's probably the biggest challenge that we see in manufacturing is how do we make more of a proactive decision about how to integrate this into the environment versus that reactive decision that forces us into maybe a gap in our long-term strategy and roadmap of how we want to scale this in a facility.
Got it. Thank you. Now, just want to stay a little bit on the technology side before jumping on the actual implementation. And Craig, I think based on what we chat before, I wanted to discuss a little bit of what are those technical limitations that robots still have to address some manufacturing challenges.
Yeah, so that's a good question. So there's a number of challenges. Before a robot can really do anything, it needs to be able to perceive the environment. It's got to know what's out there. Unless it's pre-programmed and it's doing the same activities over and over again, it's got to understand that. And perception is still a big challenge. Understanding what objects in the environment, if you need to pick them up, how to grasp them. And then we talked about the end effectors just a little bit ago. And what their capabilities are and what you're able to do with it. Second challenge is dealing with when things go wrong. So I can tell you a story that we went and visited a factory many years ago, and as we were doing a tour, it was an automotive parts manufacturer. Alarms started to go off and lights started to go off, and I thought we were under attack actually. And our tour guide went and said, "Excuse me for 1 second," and he walked over to where it was happening. And he pushed a button and he opened up a case and he took a part that was on the assembly line and he moved it over about 3 inches and then said the robot can continue. Right. And what happened was the robot expected the part to be in a certain location and it was just a little bit off. And the robot didn't know what to do. So having the robot be more agile to understand that things will go wrong, things will drop out of its gripper, parts will be in different locations, and understanding how to adapt to that, changing their activities to make sure the goal is the goal was able to be accomplished. So there's lots of challenges, but in my opinion, perception and kind of the general agility challenges are things that we need to overcome to really get the full capabilities out of the robots on the factory floor.
How far are we from that?
We're getting there. Perception is getting better every day. There's all different types of sensors, LiDARs, cameras, many other things that are being used. And so I don't know when to tell you that we got there, but I can tell you that we're making progress towards getting there. So the robots can do more and more things. With respect to agility, that's a tough challenge. And it's a tough challenge because if you think of, for example, a 2-year-old that comes in that needs to move a part around or recognize a ball or something, it's really amazing that the 2-year-old, what has to go through the 2-year-old's head to be able to understand what he or she needs to do in order to be able to accomplish that. And putting that knowledge inside of a robot, understanding the environment, understanding the robot's capabilities, understanding the goal that's going to be provided, understanding when things go wrong and how to address them when they go wrong is a tough challenge. We're making progress, and AI is playing a big role in that, and having the robot be more adaptable to changes in the environment. Ontologies and formal knowledge representations help quite a bit with the reasoning aspect, but we still have a ways to go.
Well, perfect. Thank you, Craig. Now that you mentioned AI, which is a very interesting topic now, everybody's talking about AI now and ChatGPT. I would like to for you to share. You guys share with our audience what your thoughts about the role of AI in robotics. And this question goes for Andrea, because I think Andrea, you share with us some information about AI in robotics, and I would like to know first your thoughts about this.
Well, I think that the perfect application area for AI is robotics, being embodied in the physical world in the way that robots enable is, I think, one of the best ways of opening up the transparency of what are effectively kind of black box systems. And I have a lot more concerns about the use of AI in more, distant realms than I do about the way that we utilize it to, as Craig was talking about, to augment perception, really to make sense of the parts of the real world that robots can sense, and to allow what has been the most significant change in the last 10, 20 years has been that we now have real-time, real-world navigation abilities in robots and smart devices. And that doesn't just allow for self-driving vehicles, autonomous mobile robots, but it allows for cobots and collaborative robots. It allows for a robot arm to have a better sense of where it is in the world in relation to itself, to its task, to other objects around it, which could be other robots or it could be people. And now we are getting this on chip, on camera chips, for example. So the cost of sensing is dropping dramatically as the cost of computation has gone down. And that means that we can now get a whole lot of object recognition packed into the same chip as the camera that is doing the detection.
Well, and I bet also the energy consumption will probably allow independence to the robot. Now, in that sense, and I want to stay with you, Andrea, what other applications do you think robots will be able to go beyond probably than the normal kind of manufacturing change what we've imagined them today?
Well, I think we're still not reaping the benefit of robots being able to work alongside people. And I believe that calling them collaborative robots is a little bit of a misnomer, because it's really about a collaborative workspace. And any robot can be collaborative if the workspace is designed to allow safe interactions. And that's the case of adding the perception and the intelligence to the outlying area, to the environment, as well as to our devices. This is the low-hanging fruit that we're just starting to see implemented in factories and in warehouses. And there is so much more we can do there.
Understand. Thank you very much, Andrea. Now that we have positioned kind of the technology-wise what robotics can do today, I would like to put this question to the group. and is really how easy it would be for small manufacturers to adapt robotics, because this is when we talk about investment, and I think Leanne touched on that. I mean, a big company, big manufacturer could have the pockets to do that. But I would assume that a small manufacturer, probably, I don't know, 20 people in a small warehouse, this could be challenging, the amount of capital that has to put in it. So what can you tell us, the audience, about the opportunities and challenges that the small manufacturers will have to use robotics?
I'd like to dive in on that, actually, because it's both the best of times and the worst of times for small manufacturers. It's the best of times in that robotic systems have never been more affordable or easier to use than they are right now. It is completely possible to get very affordable systems that you don't require any expert assistance to set up. The problem is, how do you find them? Those are still comparatively small companies with limited distribution, and the large companies have found them first. That's the problem. That's what keeps me awake at night, is trying to work out how we can rapidly scale sufficient robotics and automation to meet the needs of the small enterprises.
Thank you, Andrea. Yeah, who wanted to jump in? Sorry.
Yeah, I mean, I fully agree with that this is the best time for small manufacturers, but it's also the worst of times because they are getting sort of overwhelmed. Their concerns right now are very day-to-day of how am I going to get this stuff? How am I going to get done? Johnny called in sick. I'm short on the press. They have all these problems. But now that you have business models and being offered as like robots as a service, this is a great way where you don't have to have those huge capital expenditures that a large company can absorb and write off on their taxes and call it a day. The smaller guys can actually, though, look at some of these robots as a service features and literally just lease their robots.
We just explain how the model works, Aaron, to our audience.
Yeah, I mean, robots as a service, in a nutshell, is you lease a robot month to month to month. The contract can be sort of structured where you have to sign up for a minimum of so much time, but you can expense that every month. So if you're got a mobile robot running around your facility, you might be charged $500 to $1,000 a month for that robot. But as Andrea brought up, everything comes along with that. All the tech support, ongoing software updates. You don't really need to be a robot expert because as part of your service, not only are you getting the hardware, you're getting all the support behind it. So if there needs to be a programming change, they'll come in and do it. Something broke on the robot, they'll ship you a new robot and you ship back the broken one. So it's a great way to get started and not at a high cost point. And also you don't have to worry about how much do I have to train all my folks. So it's as Andrea brought up, is how do you get those small guys to even know this exists? And I agree. That's what keeps me up at night now too, because they're living day to day. So how do you get them to even know that this business model exists for them as an option so they can get robot one in the door? And I think that's the key.
Yeah, to maybe expand upon that for a second too, because I think the rise of the as a service model and the decreasing cost of tech are both absolutely making this accessible for the wide breadth of manufacturers in the space. The other thing I'd add to that though too is, and Aaron hit on this, they're resource constrained. They're worried about who didn't show up for work that day. So transitioning out of that reactive to proactive space is number one. And then once they do, being able to sift through the plethora of options on the market today is a big, big challenge, and having the time and the expertise to resource that and make decisions that are the best for their business is the next challenge then that they face.
So one thing to add there, in addition to what was being discussed, there are things that robots are good at, and there's things that robots aren't good at. If you're dealing with flexible materials, for example, that's still a big challenge for robotics, right? So large companies, small companies, it doesn't make a difference. It's very hard to be able to do that. And robots are very good at doing repeatable tasks. So for example, if you have large lot sizes, even for a small company, if they have large lot sizes, robotics could be a great solution for them because the robot's doing the same thing over and over again. You don't have to worry about people having repetitive motion injuries and doing things that, as we talked about before, were dull or repetitive, but that's a perfect thing for a robot to do. But if you're creating customized products, something that's different for each person, then that introduces some challenges for robots. So it's not only the robots of a service, it's really for a small company to look at what they're producing and the characteristics of what they're producing to see if robots will indeed work for them.
Thank you. Those have been really great points. Now, if I am a small company and I want to start the process, where should I start looking then? Go ahead, Andre.
In many ways, this is where an industry association like Silicon Valley Robotics has an important role to play. We were formed by robotics companies to initially support the companies themselves, raising investment and reaching out to their market. But it doesn't stop at that first market partner, which is often the larger company. It's also about how do we help get the message out? How do we amplify the stories of the new robotics companies that are coming out that could be really relevant to your manufacturing, but how do you know that and how do you trust that? And the average age of a robotics company today is 5 to 6 years. So we know many businesses expect 20 years of history before you will do business at all. I mean, that's kind of classic in aerospace and so on. But that's not the case with many of these robotics companies. In fact, in the autonomous mobile robot space, the category leading companies were all formed in the last decade.
Thank you, Andrea. So, I mean, I'm a small company. I approach an association. I learn about the suppliers and all that. Fantastic. There is another issue that I still have to overcome, and it's the safety of my employees. In my mind, I have robots in cages, like far away from the employees, but I'm small, and I may need the robot to work side by side with workers, so human workers. So, how is safety approached now when it comes to robotics in the manufacturing floor? That's a question for the whole team. Like, who wants to start with that?
I can speak to it a little bit. I mean, there's standards in ANSI and in what used to be known as RIA, now A3, that have defined standards that safety for collaborative robots. And there's force and power limiting, and there's distances that or how fast the robot can move when the person's next to it. And a lot of these collaborative robots follow those standards. And they once they do, they can say we're conformant with these standards. It doesn't guarantee that there won't be an injury, but what it does is greatly lessen the probability that there will, based upon if a person is interacting closely with the robots. But there's limitations to those robots. Those robots can't apply a lot of force, so they can't pick up heavy things. And so if you're dealing with very heavy objects, then sometimes it's difficult to work collaboratively with the robot. But if you're dealing with smaller objects and co-assembling something, then there's the specifications that they can follow to make sure it's too strong of a term to help to ensure that there will be a safe environment for the employee.
That's a good point.
Craig raised great points there. And I think what we're seeing now is the expansion of that caged area to being able to be the entire work area. And that comes down to your risk assessment. And it doesn't matter what safety standards there are. Every facility owner goes through that process of conducting the risk assessment. And I think it's a really good thing for us to start looking outside of a cage, because that's a kind of false security. Those robots are still capable of, all robots and all machinery can be capable of doing damage. But now we can protect, or at least we can add perception to the entire factory and create far more in the way of safe zones and warning systems than we ever could before.
To piggyback onto that point, one of the issues I think that people have in perception is that what is the cage designed for? The cage in general, most companies design these to keep people out. They're not there to keep parts in or robots in. That's not their purpose. In general, they are only there to keep people from putting their hands in and preventing them from putting hands in a place that they shouldn't go. So you have to realize that a lot of times that these cages that we construct are just out of very light gauge material. These aren't like bulletproof Lexan that we're going to that level. These can be still breached in the right circumstances. We integrate a lot of times with robots on stamping presses and things like that. When you get an inertial load of moving a part at a high speed to try and move it in, you have the weight of the part, you have the weight of the mechanism moving that at a very high rate. And if it slips or loses control of that part or just fails, that part is just like a bullet going off. So you have to understand what you're trying to do with the safety. And integration is, without question, one of the areas that always struggles. We're getting better at it, but it's an area that we still struggle with, is integration with who has control of what safety and what happens when this fails or this happens. As you said, the robot where it was continued to run and it was setting off an alarm because the robot didn't understand or know that the part wasn't being gripped anymore, but it was maybe jamming the machine from moving. Those kinds of things happen, and there has to be more work to be done in that area.
Yeah. I was going to say, yeah, go ahead, Leanne.
I was going to say, I think the key in that risk assessment methodology too is ensuring that it's safe and productive, right? So evaluating the interaction that is required and having that done so that it is compliant with the standards that are associated with the application, but making sure that it's safe and productive for the employee, because our traditional method of designing the hazard out is not going to be applicable when you're working in a collaborative environment. And that's really the model that we want to get to.
Yeah, and I would just, to put a bow on all this, because this has all been great, is that it's very, it should be encouraged that if you're going to have a robot cell brought in, that you work with that integrator. If you're the end user, you walk through that, you make sure you're pointing out all those key things, because as Leon just pointed out, your goal here is a safe environment, but a productive environment. And the whole thing is if you're not talking to your integrator about all these concerns while the design process is even going on, then you're probably going to miss something. They're going to miss something. You're going to miss something. And then the final point of all this is when the robot's installed and it's operating, in OSHA's eyes, that robot is yours, Mr. or Mr. end user. And you're going to be held responsible for how that robot performs around your employees in a safe manner. And heaven forbid, if there is an incident, the first thing those OSHA inspectors are going to ask for is your risk assessment. So it is very key to work with your integrator. So if Dean is your integrator, you're going to want to work with him. You're really going to want to point it out. So you're all in agreement of what are you designing for safe performance, but solid performance for productivity.
Thank you, Aaron. Actually, you touched a good point that I was going to ask. It's about liabilities, because that's a small company. I also have my insurance, and I wanted to know, okay, what happens if an accident occurs? It could happen. Mm-hmm. So is the end responsible at the end of the day is the company that owns the robot. What about the robot as a service? The same thing applies?
In the eyes of current regulations, yes, you are still, at the end of the day, OSHA is not going to understand robots as a service. They're not going to understand, oh, this is the point. OSHA is going to be looking at you as the runner. You have it. It's the same thing. If I lease a car and go hit somebody, the lawyers are going to come after me. Yeah. So that's how you have to look at it. Here in the United States and similar in Canada, and there's some other countries that follow this format of As the end user, you are ultimately responsible for the safety of your workers. Period. That's it.
Now, then when it comes to the company, I mean, I put in place everything that is needed. I work with Dean to make sure that, I mean, my installation is properly done. Is there anything else that I have to do with my employees? Like, I understand that the new robots is maybe easier to program. I may not need to touch them. Probably Dean takes care of the whole thing. But then, is there any other training that I have to make sure for my employees?
I think there you do have an element of workforce development that you have to account for. You have to know that I can't just plop this collaborative robot or any robot on the floor and expect my people to know. They have to be trained. There has to be a level of comprehension that has to be transferred so they understand, even if it is a range of motion type of teaching mechanism where you're actually pulling it, moving it to where I want it to go. I want it to go in a straight line in this direction, or if it's doing an arc or something like that. You have to realize that that's going to still have to be done, and the people that you have to understand. Now, that greatly goes down as you acquire more and more of them, because if I have one robot, yeah, that's a steep learning curve. If I add 3, 4, 5, and they're all the same model and use the same formatting or a common language for formatting, that greatly goes down and their comprehension goes up. So I think there's a little bit of both that still has to occur in there.
Thank you, Dean. Now, do you think that they will be at the point, and this question is for the whole group, where there won't be human beings in the manufacturing floor?
I'm happy to take that. So I was just going to bring this up. In my opinion, the holy grail for this is not a fully automated factory. The holy grail is leveraging the value that humans bring and leveraging the value that robots bring in order to allow them to be more productive. And that touches everything that we just went through, the robots working together and safety and things of that sort. Robots are very good and will continue to be very good at repeatable tasks, good at not being tired, right? Being able to work 3 shifts and going all the way through, and a number of other things. Humans will always be better, in my opinion, at creativity, flexibility, adaptability, customizability, all the abilities, right? Will be very good at that. And the trick is to see how you can leverage both sides in order to allow the factory to be most productive, how they can work together and how they can leverage each other's strengths in order to move things forward. So as I said, I don't think the holy grail is a fully automated factory. It's this collaboration between humans and robots to get the best out of both of them.
I completely agree with what Craig is saying. And I would go a little bit further and say, well, I think we can have effectively lights out in some parts, which really relate to where are the jobs that are the most dangerous, most dirty, most difficult. Originally from Australia here, so I know that mining operations have been quite autonomous in parts of the country because we're talking about operating in, 50 degrees Celsius heat and in places that are thousands of miles away from any type of town or city. So people do not like working in places like that. And we're seeing this with the start of the space industry, where if we are going to be mining on asteroids or other locations like that, it's very, very dangerous for people. So I see us looking towards a future where humans are able to safely interact with whatever stages of the process that they want to. And that might mean remote teleoperation for some tasks that involve physical danger. And that's not really lights out, but it is saying we might have areas of completely autonomous operation, but we have safe ways for humans to be as involved as they need to be at any time.
Yeah, we can see that on robotically assisted surgeries, like where the surgeon is actually doing the operation assisted by a robot. So the robot is not autonomous, or at least not fully autonomous. Not yet, I guess.
I mean, we don't really want these inside the human body because they take up too much space. But if we can send the brain of a surgeon, the eyes of a surgeon, the manipulative abilities of the surgeon inside the human body in a tiny, tiny package, well, yes, we've completely changed the nature of the relationship. The surgeon is still operating, but they're doing it through proxy, through teleoperation.
Perfect. Thank you very much. Now, for the benefit of our audience that is listening is watching this panel and that would like to know what skills they have to learn, what would you suggest them to do? Like now that we kind of know that from your perspective, it's not going to be a fully automated pork plant, but a combination of human beings and robots. What would be those skills that those human beings will need to have in order to work together with robots?
So I can start at that. Robotics is an interesting field because it's a cross between a whole bunch of different disciplines, right? There's definitely the engineering side in there and the mechanical side. I'm a mechanical engineer by training or by education. Certainly there's a computer science aspect with programming. There's the AI side. There's even the psychology side of understanding, how people do things and how you can get the robot to do the same sort of thing. So I don't know that I could say there's one discipline or one set of skills that you would need in order to work in robotics. I believe that all of those would be needed. And it's really the combination of those skills that come together that allow us to move forward in the area.
Craig's raised another really good point there. And I think we have training courses for robotics technicians, robotics operators, which are particularly good for the sorts of systems that may have been around for longer than 10 years. We're moving towards new ways of operating robots. And it's a little bit hard to say, is there one particular thing that you need or not? But what I think we have the opportunity for is, robots can be fun. Everybody can, has access to buying some sort of model of a robot, a 3D printer, of a drone, of some sort of small for fun robotics system these days. And just to play around with that, to learn off the internet, to learn off videos, to learn through games. Now, I think the fact that a lot of working with robots has a lot of similarity to working in a game environment, whether it's the use of things like a game controller to operate a robot, or whether it's the use of simulated worlds for programming robot behavior in simulation before we use it in real world. The gaming world is a really great training ground for robotics.
Fantastic. Thank you, Andrea. Now, you touched base a little bit about what you see on the future of robotics. We have only 5 minutes left, and I would like to hear from the other 4 panelists what their vision is of robotics, of the application of robotics, let's say 10 years from now. And I would like to start with you, Leanne. How do you see robotics being 10 years from now, the applications?
It's funny you asked that, Edgar, because it is so fast evolving. We talked earlier about the plethora of new companies entering this space and the average age of companies. I think the world is our oyster. I think we talk about the application of AI in robotics, and I think that's probably the most exciting development that we're going to see evolve in the next 10 years. And I think what you'll see is much smarter robots that are able to be much more agile, much more flexible and adaptable in how they interact with the system. And that changes the role of the workers that engage with them. So I think it's hard to say.
Of course. Thank you, Leanne. Craig, what about you?
Yeah, so first of all, I completely agree with Leanne and what she said. I think AI is going to have the biggest impact on robots. Robots is, right now are able to do, as I mentioned a few times, repeatable tasks. Getting them to be more flexible and being able to adapt, I think, is super important. AI is going to help to allow them to do that. So I don't think there's many areas that robotics can't help with. I don't think they're going to be able to do it completely by themselves, but I think they're going to have a role. And I think some of the capabilities that we talked about before, perception, adaptability, and things of that sort are going to really have an impact. So I think the words from Leanne were the world is our oyster, and I completely agree with that. It's just a matter of where the need is and where we need to adapt them to, but I think they're pretty general purpose and they'll be able to be used in a lot of different areas.
Thank you, Craig. What about you, Aaron?
Oh, I think there's going to be so many different applications. I can envision you're going to wake up in the morning, you're going to get your coffee made. You're going to have to dodge your Roomba at your home or your Alexis robot and giving you the news. You're going to get to your factory. You're going to program your machine tending robot for the day. You're going to maybe interact with some mobile robots at your factory floor as it's moving product around. When you leave and walk past the solar farm outside, you're going to see the mowing robots mowing all the grass under all that. You're going to go to your favorite restaurant and a waiter robot's going to bring your food out to you. And who knows, maybe your car will drive you home that evening. I don't know. It's going to be amazing. You're going to see robots in so many different industries across the board. They're going to be in our work lives and in our personal lives at home and in our public lives. So I think we're only touching the beginning of what's possible. And I just like to see more robots in the education program so we actually can prepare kids to see how these robots are going to impact it. I'm a firm believer that I think robots should be in geometry classes, because if you're going to teach XYZ, that's what a robot operates on. So I think that's in the stories of the kids saying, when am I ever going to use this? And like, there's a robot. Go program that robot on XYZ. And now you know.
Thank you. Dean?
I think we have already started down that path of how far we can take this. And there's going to be more opportunities as we go along. If you look at, and to speak to Taryn's brought up a great point, and that's education standpoint. We have Lego robot competitions right now. There's other forms of that, whether it's the first robotics competition and things like that, to get kids interested. Kids are interested. They love it. And to watch these kids compete, they just are blown away. And they come up with new ideas, and with the new things that we're seeing now with the way we can manipulate parts with the end effectors. I think that the way we're going to have to be able to do it is think about, what are we trying to do at the end of the day? Where do we want to do it? It's more of a question of what can't a robot do? And that's what you should look at and say, is there even a solution for those?
Fantastic. Well, thank you to all of you. Unfortunately, our time today is up. We couldn't cover all the topics that we would like to, but hopefully we can cover them in the other discussions that we will have in this series. Now, we have some questions from the audience. We will have a quick break, and then we'll come back to a few of those questions that we select to answer here, and the other ones will answer it via email or other methods. So back to you, Matt.
Thank you all so much for that great presentation. As Edgar mentioned, we are going to be moving into the question and answer session. If you have a question for us today, please go ahead and enter it in the Q&A window and hit submit. We will get to as many questions as we can today. If we do not have time for your question, don't worry, we will reach out following today's session. Now, Edgar, I will pass it back to you and the group to answer some of our attendees' questions.
Thank you, Matt. So we have some questions from our audience. For time, we selected 4 of them, and we'll tell them to our panelists, and hopefully they can cover as best as they can. All other questions, we will answer them via email or through other methods. So the first questions that we selected says, should workers in factories today be worried about losing their jobs to automation? Andrea.
Yes.
Yeah.
What workers in factories today need to be worried about is their factories not adopting robotics and automation, because that is the fastest way to everybody losing their jobs through not remaining productive in today's environment. The only thing that should worry workers about robots and automation is if their facility is not doing it.
Thank you, Andrea.
And I'd like to jump in and add a few things. I completely agree with Andrea. I've been to a number of factories where I've seen instances where the job of a person there is to pick up an item from one location and move it to another location. And we talked a little bit about that over and over again. Those jobs will primarily be done by robots. Those very repetitive jobs that happen over and over again. But that doesn't mean that people are going to lose their jobs. It really just means that people are going to need to be retrained in order to be able to pick up other jobs, being able to maintain the robot, being able to do things that maybe we haven't even thought of yet because we didn't have the capabilities of the robots to do some of these repetitive jobs. We've had numerous industrial revolutions with mass production and whatever else. And I have no doubt, wasn't alive during any of them, but I have no doubt that people have the same concerns that when you have the assembly line, am I going to lose my job because we're going to be able to do the same thing and do it more effectively? And in all of those instances, jobs changed, but jobs did not get lost, right? Companies were more productive. There was more things for people to do. There was more automation. But the quantity of jobs that were there stayed the same. So I don't think that people should be concerned about losing their jobs. I think if you are doing a job that's repetitive, it's just you'll be retrained in order to do something that the robots aren't able to do.
Thank you, Craig. So we have another question. The second one says, how does automation and robotics change the skills and needs from the workforce? And Aaron, I think you covered that a little bit. So
yeah,
go ahead. Yeah.
Yeah, I mean, I think as Craig just said, is that as the robots take away some of those repetitive jobs, you're going to need to have the skills to retrain folks. And what's really great right now is that we have a lot of options out there. You could go with some of the low code, no code kind of solutions that literally a lot of folks can actually intuitively reprogram the robot just based off of that. And I would actually say we're starting to see where if you can operate your iPhone or your Android device, you're probably okay. But also, I think what we need to also be very cognizant of is these folks have been working on the factory floor. They know all the other tasks that are out there. So it's how do you upskill them to take on those tasks? And as Craig said, then you're going to start seeing them discover new things. Your folks are going to see how to better utilize the robots, because as they understand how the robots are adding to the equation across all processes, they're going to better utilize them. And I've seen that firsthand. I've actually seen where robots have gone into a factory, and the employees start learning what the robot can really do, and they start really adjusting things. They make the robot more productive, or actually give the robot things that weren't considered before. So it's more of your skills of imagination are going to come alive. And don't underestimate also your transferable skills. I've seen a lot of folks come from certain industries that with certain skill sets that actually transfer very well into those process flows. So don't worry about losing your job, but be where you're open to change and learning new things. If you're able to do that, you're set.
Thank you, Aaron. The next question says, increasing automation and robotics will create an immense amount of data. What are some of the biggest challenges and benefits of this?
I think that's a great question. And we see that continue to rise with the investments in automation. So I think, there's a few big challenges that come with it, but then the benefits are huge once you figure out how to navigate those challenges. So the primary things we see as challenges are really breaking down the silos of all the disparate systems that are capturing that data, getting that aggregated into something that's consistent and providing continuous streams of flow, and then contextualizing it. And that's where you see the rise of a lot of data science in manufacturing right now, trying to figure out how to contextualize those data inputs. But then that can bring all sorts of meaningful impacts back to the business, figuring out in a very predictive manner, when is my machine going to go down? How can I increase my throughput? What kinds of things am I struggling with? What are the data points where I continue to fail? And then you take those and you make your system and all of its connection points a lot smarter.
Thank you, Leanne. So the final questions that we have today is for manufacturers, how significant is the risk for network intrusion or hacking?
I could take that one, Edgar. When we talk about cybersecurity in general, it's on the rise. So we have to figure out ways to secure our systems. And I say systems because I don't think that you can just say robot only. It's the entire system that it's integrated into. It becomes more of an issue of how do we do that and in the best way. You see right now in the medical industries, they're talking about that if you have a pacemaker or you're doing medical training, that actual device has to meet current and future regulations for securing that device because it communicates with it. So there has to be more of that we're doing as far as in the robots community, but more so in the integration side of it. I think people think, and we talked about earlier about the integration. Integration is bringing things together, but in the world, a lot of times there's the company that's doing whatever machine this is, and this machine over here that is a robot. Well, where they come together, there's communication that has to occur. And how you communicate data needs to be formatted in a way that we can secure it and provide everybody that feels comfortable, because now you start putting people in that area with a cobot. Now there's a bigger risk from a safety standpoint if that system gets hacked. We do need to be careful with that.
Thank you, Dean. So that concludes our panel discussion today. Dean, Aaron, Leanne, Craig, and Andra, thank you very much for taking the time to be here with us and sharing your knowledge and experience. And to our audience, also thank you for sharing your time with us. We hope that this discussion is kind of beneficial to you, valuable to you. And we hope to see you in our next discussion of this panel series. So we're also grateful to Rockwell and their staff experts that they are doing their part to bring smart manufacturing into reality with each passing day. And finally, to Global Spec, thank you to the million of technical professional engineers who have allowed us to connect them to the parts and services they need for project success. So Matt, back to you.
Thank you, Edgar. Now just a few items before we end things today. I would like to say a huge thank you to all of the panelists today and to Edgar for leading our discussion. And a special thank you to Rockwell Automation for sponsoring this Realizing the Potential of Industrial Robots series. Today was session 1 of our 4-part series. Please join us for the rest of the sessions. You can visit our series page using the link listed in the resource widget. Sign up for all the sessions today. You won't want to miss it. And one last thank you to our audience members for being here with us today. You will be receiving an email from us with a link to the on-demand version of this presentation, so you will be able to come back and watch this again or share it with your colleagues. Again, thank you for taking the time to attend this Global Spec series. Take care, and we will talk with you soon.